Let's say that you know the sine of theta. Is there a way to determine sine of half of theta? So for example, you know sine of 30 degrees. Is there a way to know the sine of half of that angle? So sine of 15 degrees. What we can do is take our power reducing formulas and adapt them and establish 3 more identities. But first, let's look at letting theta equal alpha over 2 in each one of these identities. So sine squared of theta, this is our power reducing formula, will become sine squared of, instead of theta, we'll write alpha over 2 equals 1 minus cosine of, and instead of writing 2 theta, we'll write 2 times alpha over 2, which simplifies to just alpha. So we have 1 minus cosine of alpha all over 2. Likewise, cosine squared of theta becomes cosine squared of alpha over 2, which equals 1 plus cosine of alpha over 2. And tangent squared of theta will become tangent squared of alpha over 2. So we'll have 1 minus cosine of alpha over 1 plus cosine of alpha. Now in each one of these, we will now want to take care of the exponent. So instead of sine squared of alpha over 2, we will want just the sine of alpha over 2. So we can take the square root of both sides. But remember, whenever we take the square root of both sides, we must insert a plus or a minus. So here we have our 3 half-angle formulas. In each one of these, they were derived from the power-reducing formulas, and we have this plus or minus in front. And the plus or minus depends upon which quadrant alpha over 2 lies. So you have to know the quadrant that alpha over 2 lies in. Now, I don't memorize these. I usually derive them directly from the power-reducing formulas that I do have memorized. But that's up to you. So in this example, we have a triangle that relates to theta, but we are asked to find the sine of theta over 2. So let's go ahead and first find the missing side, which is the hypotenuse. Now you might recognize that this is a 7, 24, 25 right triangle, or you could use the Pythagorean theorem and determine the missing side by using a squared plus b squared equals c squared. So 7 squared plus 24 squared would equal 625, and the square root of 625 is 25. So let's look at the sine of theta over 2. It is equal to positive or negative, and that will be determined later, of the square root of 1 minus the cosine of theta all over 2. Now let's evaluate that expression. That's positive or negative, the square root of 1 minus, and now cosine of theta is 7 over 25. That's all over 2. Now, that's positive or negative. And now, one way to simplify that radical is I'm going to extend the radical, and I'm going to multiply the numerator and the denominator by the LCD. But I only have one denominator, 25. This 2 has the denominator of 1. So I'm going to multiply the numerator and the denominator by 25. And that yields for us 25 minus 7 over 50 for the radicand. Now 25 minus 7 is 18, and 18 over 50 reduces to 9/25. And now the square root of 9/25 is 3/5. Now, are we going to use the positive or the negative? And because theta is an acute angle, theta resides in the first quadrant. And therefore, if I divide by 2, that would also reside in the first quadrant. An acute angle divided by 2 is still acute, and the sine of an acute angle is positive. So our answer is just positive 3/5. We can disregard the negative. Now let's look at the cosine of 165 degrees. So the cosine of 165 degrees can be rewritten so that we have instead cosine of 330 degrees divided by 2. Now, using the half angle formula for cosine, this is positive or negative the square root of 1 plus cosine of, and the angle we're dividing by 2 is 330 degrees over 2, and that completes the radicand. So plus or minus, now 1 plus, what's the cosine of 330 degrees? 330 degrees has a reference angle of 30 degrees and it's in the fourth quadrant. So cosine is positive in the fourth quadrant, and the cosine of that reference angle, 30 degrees, is the square root of 3 over 2. We will again use our trick of multiplying the radicand's numerator and the denominator by 2. So I'll extend the radical, multiply by 2 in the numerator and the denominator, and that yields for us 2 plus the square root of 3 over 4. So this is equal to, in the numerator we have the square root of 2 plus the square root of 3. The square root of 4 is 2, so we can eliminate the radical in the denominator. And cosine of 165 degrees, is that positive or negative? Because we have positive or negative all throughout here. Which one do we choose? 165 degrees is in the second quadrant, and cosine is negative in the second quadrant. And so we have arrived at our answer. Let's look at a similar example, but this time we're in radians. So the tangent of 7 pi over 12 can be rewritten as a half angle. And what is 7 pi over 12 half of? 7 pi over 6 divided by 2 would be 7 pi over 12. And so this will be plus or minus the square root of 1 minus the cosine of 7 pi over 6 over 1 plus the cosine of 7 pi over 6. And so we have plus or minus 1 minus, and now the cosine of 7 pi over 6 is based on the reference angle of pi over 6. So cosine of pi over 6 is root 3 over 2. And 7 pi over 6 is in the third quadrant, where cosine is negative. And so we have 1 plus cosine of 7 pi over 6 would be 1 plus negative root 3 over 2 in the denominator. And so simplifying some more, we have positive or negative, 1 plus the square root of 3 over 2 over 1 minus the square root of 3 over 2. And since we have a fraction within a fraction, we will use the trick again of multiplying to clear the fractions in the numerator and the denominator. And so we have positive or negative square root of 2 plus the square root of 3 over 2 minus the square root of 3. And now we can get rid of the radical in the denominator by multiplying by its conjugate. So 2 plus the square root of 3 over 2 minus the square root of 3, and we will multiply by the conjugate of the denominator would be 2 plus the square root of 3. So we have positive or negative. The square root of 4 plus 4 square roots of 3 plus 3. And in the denominator, we would have 4 minus 3. And so we have plus or minus. In the numerator, we have 7 plus 4 square roots of 3. And in the denominator, we have just the square root of 1, which is 1. So we have 7 plus 4 square roots of 3. And are we going to choose positive or negative? 7 pi over 12 is just beyond half a pi. So therefore, this is in the second quadrant, and tangent is negative in the second quadrant. So here we're given sine of u is negative 5/13. But we want to find sine of u over 2. Well, let's go ahead and sketch sine of u. Notice that u is between pi and 3 pi over 2. So that means that we are in the third quadrant with u. So there's our angle u. And if we drop a perpendicular to our horizontal axis, we can sketch a triangle with sined legs. And this is a 5, 12, 13. And notice that the adjacent side we could use a directed distance of, or directed length of negative 12. So now we know that sine of u over 2 is equal to positive or negative the square root of 1 minus the cosine of u over 2. So that's positive or negative the square root of 1 minus, and then cosine of u, according to our diagram, is negative 12/13 over 2. Now this yields for us positive or negative, and 1 plus 12/13 all over 2 is 25 over 26. So if we simplify that, we have plus or minus 5 over the square root of 26. Now we rationalize the denominator, and we would have 5 square roots of 26 over 26. Now, will our answer be positive or negative? And for that answer, let's go back to our interval. We know u is between pi and 3 pi over 2. But we want to know where u over 2 is. So let's take our interval and let's divide each quantity by 2. So this tells us that u over 2 is between pi over 2 and 3 pi over 4, which means that u over 2 is in quadrant 2. And sine of an angle that's in the second quadrant is positive. So we will use the positive version of our answer.